Hey there, welcome to my channel Chemistry Not Mystery. This channel features conceptual chemistry. This is the first video of this channel, and to get more such videos, don't forget to subscribe. You can also visit to my website chemistrynotmystery.com. After watching this video, you will be able to write the electronic configuration of first 20 elements of the periodic table. First, try to understand what is electronic configuration. According to the quantum mechanical model of atom, there are quantized energy levels inside the atom, and electrons are distributed among these energy levels in increasing order of their energies. The distribution of electrons in these energy levels is called electronic configuration. So, what are these quantized energy levels? You can understand it as we compare an atom to a building. Then floors can be compared with the orbits or shells, flats with the subshells, rooms with the orbitals, and individuals with the electrons. Orbits can be compared with the floors. As we go up in a building, potential energy of the floor increases. Similarly, energy of orbit increases as its distance from the nucleus increases. Subshells can be compared with the flats and rooms can be compared with the orbitals. There are 4 types of subshells depending on the number of orbitals in it. 1 room flat is named as S subshell. 3 rooms flat is named as P subshell. 5 rooms flat is named as D subshell. And 7 rooms flat is named as F subshell. Energy of the subshell increases as the number of orbitals increases in it. Orbitals of the same subshell have similar energies. Each orbital can be occupied by a maximum 2 electrons. S subshell has only 1 orbital, so has the lowest energy, and F subshell with 7 orbitals has the highest energy. Each orbit has different types of subshells, as each floor has different types of flats. First orbit has only S subshell. Second orbit has S and P subshells. Third orbit has S, P and D subshells. Fourth orbit has S, P, D and F subshells. Filling of electron is governed by the Aufbau principle. Aufbau is a German word meaning building up. Electrons are filled in different energy levels in increasing order of their energies. That means electrons are first to be filled in the lowest energy level. Let's try to fill the electron of hydrogen. Its atomic number is 1. That means it has only 1 electron. This only electron goes to the first orbit in S subshell. Here the electron is represented by a half arrow. This information about the filling of electron is known as electronic configuration, and it is written as 1s1, where 1 denotes the number of orbit where it is placed, S defines the type of subshell, and 1 written in the superscript defines the number of electrons present in that subshell. Now, try to fill the electrons of helium. Its atomic number is 2. First electron will go to the first orbit in S subshell. Since each orbital can be occupied by a maximum 2 electrons, so that the second electron will also go along with the first one. So, its electronic configuration will be 1s2. Next element is lithium. Its atomic number is 3. First electron will go to the first orbit in S subshell. Since each orbital can be occupied by maximum 2 electrons, so that the second electron will also go along with the first electron. But now, first orbit is full, so the third electron will go to the second orbit in S subshell, as it has lower energy than the P subshell. So, the electronic configuration of lithium will become 1s2, 2s, 1. When you add the numbers written in the superscript, you will get the total number of electrons. Here, 2 plus 1 equal to 3 electrons. 2 electrons are present in S subshell of first orbit and 1 electron is present in S subshell of second orbit. Next element is beryllium. Its atomic number is 4. 2 out of 4 electrons will go to the first orbit in S subshell as we did before. Remaining 2 electrons will go to the second orbit in S subshell and its electronic configuration will be 1s2, 2s2. Next element is boron. Its atomic number is 5. 2 out of 5 electrons will go to the first orbit in S subshell. Next 2 electrons will go to the second orbit in S subshell. Now S subshell is full, so the next electron will go to the P subshell of the same orbit. Now you will write its electronic configuration as 1s2, 2s2, 2p1. I hope you understand till now. Now, with the example of carbon, I am going to introduce the second rule, that is Hund's rule of maximum multiplicity. Atomic number of carbon is 6. 2 out of 6 electrons will go to the first orbit in S subshell. Next 2 electrons will go to the second orbit in S subshell. Remaining 2 electrons will go to the P subshell of the second orbit. But these 2 electrons are not going to share the same orbital, or you can say the same room. As I told you before, the orbitals of the same subshell have similar energies. And according to the Hund's rule of maximum multiplicity, electrons will remain single until all the orbitals of that subshell are singly occupied. Now, its electronic configuration will be 1s2, 2s2, 2p2. Similarly, you can write the configuration of nitrogen. Now, come to the oxygen. Its atomic number is 8. You can distribute its 7 out of 8 electrons as you did before. 2 electrons in S subshell of first orbit, then 2 electrons in S subshell of second orbit, then 3 electrons in P subshell of second orbit. Here, you fill 1 electron in each orbital of P subshell according to the Hund's rule of maximum multiplicity. Then the remaining 1 electron will get paired with another electron of first orbital of the P subshell. That means 5th electron and 8th electron will share the same orbital. You must have noticed here, whenever I draw a paired electron, I denoted one with the up arrow and other with the down arrow. You also have to follow the same rule, but I will explain it in the coming video of quantum numbers. Try yourself to write the configuration of other elements, those atomic numbers less than or equal to 20. If you have any doubts, please post in the comment box and don't forget to subscribe the channel. Thanks for watching.